recording is cool. So yeah, I can share my screen. Step one. So you can see my screen now?
Yep.
Yeah. So I started the implementing the concept of fields or accessors in Imba as a special type of property on classes. And the main reason behind it was that, as you know, we've been working on the data layer for the next version of Scrimba. And to allow creating these rich fields, we had a very hacky sort of meta language that used proxies to see when you try to set fields in a class. And we used a lot of magic to be able to add that functionality that I have now built in as more of a basic part in the language, which makes it more performant, easier to grok, and also it supports typings, which was one of the most important things. And I can just take you quickly through a few examples. So the idea is that I find in a lot of cases, let's say you have a model, let's call it a user. You have a class, a type of object, and it often has a bunch of properties, right? It may have a name, it may have a description, it may have some more like richer types of properties. So it could have a permissions object maybe that has a lot of complex functionality. And the idea is to be able to make these rich fields that can themselves decide how to behave when you try to set their value from the outside or get the value. So as a regular field, you have the user, let's say you have name, username, Sindre, then user, new user, and user.name. So that's a string, right? And you can set it and you can get it. It's just a regular ES class field. So the thing is, if you want to hook this up to some sort of model or some backend, then you have a few different options. So you could start using decorators. But a problem with decorators, there are many problems, but one problem with decorators is that they are not standardized at all. So there are a bunch of different decorator implementations and proposals floating around. The current proposal, like TC39 decorators, something, is probably the one that will be added to ES, to JavaScript at some point. But that's not the proposal that people are currently using in Babel and other places. So as you might have seen, a lot of libraries are starting going away from decorators. And that's because, it's a very eerie situation around like what is going to work and what is not going to work in the future. And another big problem with decorators is that they don't really support typings that well out of the box. So the idea I wanted to have, like I wanted to be able to somehow say that, so define the field itself here. Let's say I have, I'm just text property. I wanted to somehow be able to define here that this is going to be a text property and it's going to be max length 12 and it's going to be persisted true or whatever, like persist in local storage. This is just imaginary code, but imagine having, you want a way to be able to define all these types of rich fields for a model, for a class. And you want to be able to access the metadata here at in some way. So when I create a new user and call user.name, I obviously want to get the actual value of the field, right? I want to get the name of the user. Under the hood, it might actually do something here, right? It might not be an actual plain property, but the getter for user.name should return the string, like the name of the user. And likewise, if I do user.name John, then it should also like do something, like the property should be able to decide how it will handle being set. But from the outside, it should look just like a regular property or a regular field. And also, there might be important information in these properties. Like here, I added a max length. And somehow I would want to be able to access like the actual field, not the value, but the field that the value is for. So maybe I would have this sort of property that actually returns the property or the accessor itself and not the value. And for typings, I would also want to have like, I would want the user.name to be typed correctly. And I would want the actual access to whatever accessor to be typed correctly. But as you can see now, if we use this approach, then user.name is of type text property, which is wrong. And I could manually add like a type here, but then you would probably see that there's an error here because text property is not assignable to the type string, right? So there are all these sorts of problems with it. So I added a new concept in Imba. The syntax for it might not be perfect yet, but the whole idea is that when you define a property in a class, if you write an at like property name at, and then an expression afterwards, the expression after will kind of be taken as the rich accessors responsible for getting and setting this name. So behind the scenes, before I go into the actual internals, behind the scenes, this declaration here would almost compile to something like this, like name, text property, get name, name get, or I'm going to show you why it's more complex than this, but set name value, name value equals value. So this would be one way to go about it. Here, then we could set specific typings for the value, and the type for this would still be the same, right? So if I now do user.name, you will see that the type for that is text property, and the type for user.name is a string. But this is a lot of code, and it's pretty, you don't want to do this all the time, and you want to probably have different types of properties to be able to do this. No, different types of properties that works in different ways. So with this syntax here, I should probably create an actual working example. I'm going to remove this, and now I'm just going to start with a getter and a setter, and I'm actually just going to do this. This is very plain, but you will see how it works. So if I terminal, whoops, Imba examples basics. So if I do console log user.name, I can run it continuously. You'll see that it now returns John, right? So we're setting the name. The only thing the setter now does is that it redirects and sets the dunder name instead, like the double underscore name. Now we want to turn this into a property instead. No, an accessor. So I'm going to create the class text property, name at text property. I can even do new text property. And then I'm going to remove this. And now it's going to crash. So what's going to happen now? You'll see that it's set at name.set is not a function. So these properties has to follow a certain convention. There has to follow an interface that is declared in the Imba typings now. But essentially what they need to have is two functions. So they need to have a set value return and a get value return. So if we call this now, you'll see that nothing happens. It returns undefined. Get value was wrong. It's actually get target. I'm going to get back to the arguments. So if I always return this here, you will see that user.name will now return this value here whenever we set it, like whatever it's set to, because we don't do anything in the setter. Set is called with a bunch of arguments. So the first one is the value, which is the value you want to set something to. The second one is the targets, like it's the self, the user, the object. So I could now do set underscore name value here, target underscore name, and on get I could do get target name. And this will work now. So you will see that it actually returns John. And you can hook into things in these getters and setters. But this is very narrow, because you can create these properties not only for name, but for any other thing, right? And you don't know what, whether or not the, even if you knew that the property was for name, you don't know for certain that underscore underscore name is not already used or is not some other field. So in addition, you also have a separate argument, which is the key. You get that for a getter and a setter. This is a unique symbol representing this field. So it's actually a symbol, which means that you can always set that as a property on an object without ever having to worry about naming conflicts. So essentially, if I now do target key value, that's all I do in this setter, and I do target get target key here. Then we'll see that it works. And if I do a prop desk, user desk something, you'll see that it actually returns different values. It's not using the same target, like it's not using the same key. Both of these properties now are unique properties, and they are called with unique keys. But now, just to show you the concepts here, if I predefine this like const textual, and I just predefine it here, I can set, essentially what I'm saying here is that I want this object here to be the manager for setting and getting a certain value on this user instance there. So both the name and the desk are going to be sort of proxied to this text property. But under the hood, it will still call it, even if it's the same actual property, it will be called with different arguments, right? It will be called with a different target if it's called on a different user, and it will be called with a different key when it's a different property. So it still works, even if I'm now just reusing the same field. Also,
can you get the list of keys that have been used? Can you get the list of keys?
List of keys, what do you mean? Like list of actual fields on the user?
No, inside the text property, can you access the other keys? You have the current used key, but and the other keys, can you access them? So right now there's name and desk, and how would you get the other symbols?
Yeah, so that depends if you want to get the other symbols. You can do that, because I'm going to show you that there are quite a few additional arguments to both the getter and the setter. And there's also a different property in a method that I haven't even talked about, which is always when it creates the actual accessor, then it tries to see if there is an accessor method on it. And then it will call that that method. I think it would probably be easier for you to understand by looking at the compiled code, even if it's quite complex. It will look messy, and that's because of the performance things. Because this type of approach here, I want this to work and be fast for cases where you might have hundreds of thousands of instances of classes, right? And then it has to be fast, like the getter and the setter has to be fast, but it also has to be quite memory efficient. And what you don't want to do is to always actually create an actual field object for each property, because most of these properties will often be like numbers and strings and and very simple properties, and you don't want to create copies of every accessor on every instance. But sometimes you might want to do that. And that's why the interface, like the code we generate here, allows you to choose, like on the implementation side. So I can actually take you through it. If you look at the code here, editor, see basics. So it creates a bunch of code here, and this is the thing you that is interesting to see. By the way, all of these meta properties here, they are possible to access using what is currently a double @ syntax. So user @ name will actually return the meta property for the name. It's actually weird that that resolves to the anytype now. I'll see. We can see why that happens. But this is a code it creates. So what you can see that set name and get name, it creates a getter and a setter, which only forwards the call to this dot @ name, like @ and the name of the field you defined. And it calls sets with the value of this, the unique symbol, like the unique slot where you can actually store the value if you want to, and the name of the property. But when you see, when it accesses this dot @ name, it actually triggers this getter right here, which is more interesting, which does a lot of things. So if we don't talk about this just yet, it returns the value that you, the expression that you actually defined here. It wraps this in an Imba accessor helper with a ton of arguments. So it includes the actual expression of the field that you defined, the value of this. So again, when you call this on an instance of user, it will actually run this function. Every time you call set or get, it will actually run this getter here and call the Imba accessor and all of the properties to return the getter. And it returns a bunch of additional things. This is not really needed. I'm going to remove it, but it returns the expression itself, the value of this, the unique slot where you can store the actual value, the underlying value, the name of the property, and an additional unique slot that I will get back to, and the object on which the field is actually declared. I'm just jumping back and forth now, so please ask questions. That might be a better way to go about it, but until then, I'll just continue trying to show some examples.
So far, so good.
Okay.
It's important to like finish the full thought. I'm with you still.
Yeah. So that's the thing, just to show you how I can show you from start to finish how I would, or how we have implemented these rich accessors in the data layer to make it fast and efficient. So usually, let's say I want the name of the user to be a text property, and I'm just going to say prop name @ and new text property. This is all I'm going to do. In the constructor here, so it's going to be constructor. Yes, nothing's going to happen there, but I'm going to console log new text property. And you're now going to see that if I remove, I'm going to remove the other properties just for simplicity. You will see now that when I call this, it's actually going to create a text property a bunch of times, and that's definitely not something we want. So when I run it, it's called it 2 times. So just by creating a new user, it's actually created 2 new text properties. That sounds very weird that we want that, and we don't want it, but we want to have the option to hook into to decide how and when we want to cache the actual value of the rich field. So you can see now, if I do username, it's actually creating a new text property every time. So the way to get around this is that we have the additional interface. So a accessor might have a set and a get method. It also have a accessor method. And if I just look in the, I can show you the code here. It's very simple, like the Imba accessor helper is just this code. So it's essentially checking that if the value that you pass in has an accessor function, it's going to call value.accessor with the target, which is the current value of this. So call accessor on target, return self. Now you'll also see that it's actually calling this a bunch of times. Just whenever I access user.name, it's going to call new text property, and then it's going to call the accessor method on that. And the target it's providing in accessor is the user instance itself. So it's not the prototype of the user. It's not the class. It's the instance, the actual instance. So one thing I could do here, I'm going to backtrack one moment. The other arguments to accessor is key, which is again the unique symbol that we can use to store the value. The name of the property, which in this case is name, and the slot. I'm not sure what we should call it, but this is very important for the flexibility of this accessor interface. And that is that this slot is a unique symbol that you can, that is used to potentially memoize the accessor itself. As you saw in the generated code here, this is how the code is generated. So essentially, whenever we access at that name, it will check, if there is a value stored in this custom symbol, in this unique symbol on this, then it will just return that. Otherwise, it will call the accessor and all of that stuff. So essentially, when text property accessor is called here, the first time, you can see now it says like call accessor on user, call accessor on user, call accessor on user, blah, blah, blah. If I here actually do target slot equals self, what I'm doing is that I'm saying that, so for any other time that it will try to access this accessor on the target, it will always look up on this slot first. So now when I call this, I'm actually going to set it. I'm going to memoize the accessor itself here. And you can imagine you can do all sorts of other things. Now you saw that when I run it now, it's only calling accessor once, and it's also only creating a new text property once. And that's good for memory. But it's not that good because, as you will see, if I create another user, user2 here, and I set here, you will see that it actually creates two text properties. So somehow this is called 2 times. And that also means that console log user, I'm going to user.name. So this is access to the actual rich property equals user2.name. That is false. So now both of these instances have their own rich text property object for handling when you get and set the name of any user. And the reason for that is that the accessor, as we talked about, is called with the current target. And since I'm only memoizing the text property for the current target, then whenever we create a new object, it will always create a new text property and memoize it on that actual target. But as you saw here, the last argument for the accessor is the prototype on which the accessor is defined. So if I instead actually just memoize it on the context itself or the prototype or whatever, then it is going to reuse. Now you see that it's only creating one text property. It's only calling accessor once on user, like the first time you try to access that field on any instance. And the accessor itself is now the same accessor on the user and user 2. And this all probably seems a bit complicated. You don't want regular users to think about this at all. It's obviously an implementation thing that people who want to implement like rich data layers or whatever that uses these types of properties. Those are the ones who have to be concerned about how they want to do this caching. But it's very powerful to have the option, because this API allows you to yourself decide whether or not some accessors are supposed to only exist in a single copy for each class. Like whenever you define it on, let's say we define an accessor for whatever, children on a model type. If it makes sense to only have a single accessor shared across all the instances, or whether or not it makes sense to create a rich accessor individually for each of these instances, then you can choose, pick and choose in this API. And in most cases, it actually makes most sense to have a single accessor that is shared among all of the instances, because in the setter and the getter, you do get the information you need to actually set things on the targets directly, right? So even if these two users here share the same field, when you call user.name and sets it to something, you will always set it to the target, right? But maybe just for fun, it's maybe not the best example, but let's say we have a const new. I'm going to rewrite this and do class shared property. I'm going to just for fun inherit from this, and instead I'm actually going to, instead of setting the value on the target, I'm going to do it on self. So I'm actually setting it on the shared property. I'm not going to care about the target and in the getter and the setter. So now if I do prop stuff new shared property and I do user.stuff equals 100, and I'm going to do console log user2.stuff. Now you'll see that it's still going to return undefined here. So user stuff is undefined on the original user and on the other user. That seems weird, but the reason is that, as I talked about, to make the API for this flexible, it's actually going to create a new property. It's going to evaluate this expression whenever it tries to execute the setter or the getter. But if I instead defined it beforehand, are you following along on that? Because that might.
Can you do add stuff dot name or dot stuff?
Yeah, just to log it out.
Yeah, user add stuff dot and then use dot stuff.
Dot stuff.
Yeah.
No. Yeah, that
or
doesn't make sense.
Should be symbol stuff.
Yeah, because that's a unique symbol. You don't have access to it. But I could just for fun, in the accessor here, I do get the symbol, right? So I could just, in the accessor, I could return self, so we don't do any caching at all. But just to show you, I could key to store and set the key. And when you see now, when you log out this, you'll see that it's a shared property and it has set a key to store. But again, it's quite weird. But if I call this multiple times, it's actually going to return a new instance every single time. because it isn't caching. The language is not deciding how and whether or not to cache the fields. That's up to the implementer of any library that provides functionality using these accessors, because that's the only way to get it really fast and flexible at the same time. So maybe you don't want to use this thing where you actually create new instances, but if I instead did a const shared property or new shared property, and I do prop stuff at shared, now it is, whenever it calls it, it's still going to return the same field, right? No, the same accessor. So now it should work. Now user.stuff and user2.stuff should be the same value, even if I only set it on user. And as you can see here, it's still undefined. That's good. User stuff, new shared property.
The accessor, you removed storing it in the context, right?
I think it should have worked if it's set undefined. I'm probably just I'm going to compile it again just to actually see. So I'm going to look at the code. We're creating a new shared property. In the set stuff, we call at that stuff dot set and the value and target and the symbol. In the get, we do the same thing. We are always calling it with this Imba accessor. I'm just going to remove this just to see if okay, so let's try to figure out what's going on. I'm setting user stuff to 100 here. So if I try to call it, just see if that works at all. Setting stuff, value, target T. Setting stuff, undefined for, this is a bit tricky. Now I understand why. And it's actually something that I might want to change the design of. But just like other fields, they will, when you initialize a class, it will actually set the values to undefined unless you have a default value. So actually, when we created new user, it set user.stuff to undefined, no, user2.stuff to undefined. And since those two shared the same accessor, then it happened that way. So if we instead do this, and we set user stuff afterwards, now you see that it actually using the same shared property.
Yeah.
And this is again,
No, I was just going to ask real quick for my own understanding. Wouldn't it be undefined anyway if it wasn't set to anything?
No, that's the thing. So this is just as a concept, just to show you how these accesses works. This is a shared property, and as you see in the this is just a custom accessor that we invented right now, and we defined a special set and get method on this,
right,
where we, instead of setting the target, setting the value for the specific target, we just set the value for the accessor itself. So it's like whatever instance you set it from, it will update for all of the objects.
I think I'm following that part, but just kind of language level design. So deeper than that, why would there need to be an original set when the instance of a class is created, if by default kind of uninitialized stuff in JavaScript is undefined? Like, would it be like at a specific point in the compiled code here, would it set the property equals undefined? Like,
that's what it does.
Already have been undefined?
It's in the constructor, because we have the new shared equals new shared property, and you can pass initial like an initial name, initial stuff value. That's what happens.
I'm getting it now. I'm getting it now. So it's basically we can't optimize that part away if nothing happened in the constructor, or we haven't.
We continue to do that. Like Imba already changes a bit how properties are set in the constructors compared to regular JavaScript, and we could decide to make accesses work in a different way, like actually provide some.
Maybe check if there is no, it's undefined. When you do new user without passing in initial value,
Yeah,
it's maybe skips doing the sets to undefined. But yeah, it depends, because this just needs to be documented. Not a lot of people who use it. Maybe it's just Sindre and me and the neighbor.
Yeah.
And
but it's interesting though, because it kind of it opens up part of what's the underlying implementation, because right now we discovered that it was an order issue, and because it was a shared thing, we suddenly kind of saw that it showed up that it was assigning undefined the first time. But it almost feels like if we try to optimize that away, we would have even more complex like caching things if this is like, if this shared way of doing it is possible.
Yeah, I think, but again, this was a pretty poor type of example, because you would never want to have that sort of shared property. I guess it was originally, it was just to show that it's actually, it was using the same accessor underneath. But another use case for this is that you might have richer types of properties. Like, let's say we want to have a prop friends, and we do a set property. So class, I'm now, now you'll see that this does not work at all. So I call user friends, it shows that it actually, there's an error here, because user friends set is not a function. I haven't implemented that on this class, and as you saw here, I actually used a class instead of an instance. So I could have done new set property, but I want to be able to let people create these nice, clean looking, almost domain specific languages, right? To define these rich types of fields. So again, I want to skip this new here, and I just want to make sure that my class here, my field, then I have to define a static accessor, right? As we talked about, the targets there was, these were the arguments. Here I can, let's say if it's used this way, I can do return new self. Instead, I'm actually going to make it even more fun. I'm going to just do class custom set. Just going to inherit from an actual JavaScript set. And I'm going to let the field itself be, the kind of the set itself be responsible for getting and setting stuff. So I have a set property, static def accessor. Here I can essentially choose what am I going to return when Imba under the hood tries to access the accessor for a certain field on an instance. So here I'm actually going to do the target. I'm going to cache for the slot. I'm going to do new custom set with the, maybe for fun, I can throw in the name of the custom set. Constructor name, and super. So now you will see that prop friends is defined as, I set the accessor for prop friends to be set property. We will call accessor on this value of this expression. And the first time that is called, we are actually going to memoize the value, and we're going to return it directly. So now we will see the fun thing here. It's going to crash still, and I'm going to get back to that. Now it's going to crash, but in a slightly different way. This at friends.set is not a function. That's because set and get is not a function on sets. So value self def get value self. I'm just not going to do anything. Now it doesn't crash anymore. And if I remove all of this other code here, and I just do console log user.friends, you'll see that it's, the value of this is now just a custom set with name friends. And as we talked about, this is now a different kind of property. This is a property where I actually use the value itself directly. So now I can also say that when you try to get the custom set, called a getter, it makes sense to actually return itself, right? Because that's the thing you want to get. So when I do console log user.friends, I actually want to return a custom set. And you see that that's what happens. So in this specific case, the underlying field, the underlying accessor, and the value of it is the same because that's how the accessor behaves. But when you want to set it, maybe I wanted to set this user friends equals Abdella and Matthias. Nothing's happening, but it is calling set value. So in values. You see, it is actually calling this setting values, value, and not values. And it's supplying the argument is custom set, no, yeah, friends, Abdella setting values, Abdella and Matthias. So here we might want to like throw if it's you're trying to set it to an array or whatever. But let's say it's a model. So you are loading data and you're actually just loading some raw JSON or something. So behind the scenes, you want to actually see that, oh, so if value is array, I don't want to change, like replace the whole set. But if value is an array, I'm actually going to do self add for val in value, self add val. So now I'm just adding plain strings. User.friends, if I do console log user.friends, now you see that it's a set that contains Abdella and Matthias, and it has additional properties. So it's a set, but I can also do set.name, and it will actually return the name of the field it is responsible for. And for fun, I could also make it more complex. So I could include the target as well and say that the custom set has an owner and a name. So now you can see that I have a lot more information about this set. It actually contains a reference to the owner, like the instance on which the set resides, and the name of the set. And the thing is, we actually managed to hide a lot of that complexity behind the scenes. And we also get typings for free. So if you see here, like user.friends is typed to be a custom set. And that happens automatically just because TypeScript infers this by seeing that the result of set property dot accessor will be a custom set. And in this case, it's pretty simple. But what's very cool about this is that this also works for much more complex. You can supply TypeScript typings that include generics and everything to create pretty complex properties. So in the concept of the stores, maybe I have a test case here. You can actually, let me see if I have a defined. So this is a basic, this is the data layer thing that we can go through another time. But I'm essentially just creating a base model. It inherits from root, model inherits from base, entity user scrim. And so here I'm defined like scrim. I'm setting the owner property to be the value of this expression, op.ref, and another model. OP here is just an instance method on all of these entities that returns a utility object that just makes it easier to cleanly define different types of properties, accessors that does different things. And when I include an argument there, which is a user, then automatically the way the typings works, if I do let scrim use scrim, and I do scrim.owner, that is actually resolved to a type user. But if I did, I think it sets zset user, then it returns a array in this case. That's how the implementation of the field is of users. So this allows you to both get complex typings from TypeScript for these properties. So an accessor can actually tell you a lot about what type of value the accessor will have. And you also always get access to the metadata. So this returns an array of users, but scrim.owner, I will always actually have access to all the metadata and stuff that I have on the accessor itself.
Super cool. What about backlinks? So do you have the typings for them?
Yeah, but now, now you see that the backlink is any, so viewings here. I have defined viewing here. If I do backlink here and I do let's scrim, use scrim, I don't remember if they're all implemented. Viewings, yeah, now that's an array of viewings. So if I do this, you will see that it actually have some properties. And again, all of this works with go to completions as well. So scrim viewings.viewer, if I click that, it jumps to the field declaration for viewer on the viewing model. And this setup here, like this simple file here that just defines a bunch of classes with these descriptors, actually through the power of the accessors interface, this actually under the hood defines a rather rich model layer that can take care of persisting certain values, keeping other values of instances in local storage, sending things to the backend when some values have changed. So it allows you to, on the implementer side, create really complex logic that when you use it in your classes could look relatively clean and simple.
That's extremely cool, because I remember back in the day now when we were prototyping for the data layer, trying to do the EdgeDB thing and have a rich model and generate stuff. This kind of interface, it's much simpler to do, and it's going to be extremely powerful.
Yeah,
I think this has great, very big potential.
Yeah, I definitely agree.
Compared to things like Redux, where state management is just a cumbersome thing that doesn't, just to please the reconciler. This is a state management pattern that's powerful. It can communicate with, it can persist, communicate with the server, log stuff, whatever, without being in any way cumbersome to use. It's very simple stuff.
I think it's actually even, so obviously the next step that I would like to do at some point is to make it improve the syntax even further and actually implement a model keyword in Imba. So you are going to be able to use these types of fields for every class, but you could also imagine having a model type that is a bit richer and has a bit additional fancy features for typings. Like when we have a, let's say we have a user here and we have a temp user that inherits from user. When these reside in different files, etc., it's not easy for the regular typings to know when, like, which subclasses any type has, like all the hierarchy, all the potential properties of a model and all its subclasses and stuff. You could do a lot of that with a separate model thing, but you could also do the other thing that is also a very important part of the data layer, which is these composite keys. And the important thing for being able to persist objects, right? Damn, I actually have a call. Just 1 second. Let me see. Yeah, I should wrap up soon. Just briefly mention that you always want to have any object in a model layer that you instantiate, you want to have some sort of ID for that object so that you can persist it either locally or on the server or refer to it from other places. And one of the important things in the model layer in Scrimba, in the next version of Scrimba, is these predictable IDs where you can include properties of an object in the ID of the object. So a viewing here, the ID of a viewing is always a combination of a viewer and a scrim. And that means that it should only be possible to get, if you spawn like the viewing for a user and a scrim, then there should only ever be that specific object with that specific ID representing that relationship. So if I do viewing from user, let's say I have, let user new is the wrong syntax for that, but viewing from user and scrim, we'll see that it's a viewing. If I do viewing.user, no, viewer, it's saying any, and that is not right. So that's a bug in the typings. But the whole thing is that this has an ID. In our case, it looks essentially something like this, like scrim, blah, blah, user, blah, blah, scrim, blah, blah. And I could call this a million times and it will always return the same instance in the client or whatever. This would also be easier to do with the separate model keyword, because it would be very easy to create these. Like you can imagine wherever you want to do, like do model settings page for user and project, just imagine. So this would be like the definition where you could always just call setting page me current project to get the unique instance of the settings page model for this combination of arguments. But this is a tangent, but that's an important part of the model A, which will but this is
going to make it, it's going to make it easier for all of us to reason about the code too.
Yeah.
Because when it's not all class everywhere, then we can kind of attach meaning to it.
Yeah. Cool. So I actually have to go. But we can do another chat later and yeah, if you have questions. And
yeah, definitely. We still need to plan a little bit about Imba 2.
Yeah, I can call you after the other meeting.
Yeah, definitely.
Yeah. So we'll talk soon. Yeah.
Yeah, see you. Bye.